Welcome to the CART EMR Lab video tutorial series. In this video, we will be talking about creating laser cutting toolpaths. I have a sample part up on the screen, and in a previous video we covered how to create a setup for a laser or water jet part. So if you haven't done that already, go back and watch that video. We're going to apply toolpath to this particular part. So we want to make sure we're in the manufacturer workspace, and we want to switch to the fabrication tab. So if you're on milling or turning, just click on fabrication at the top so that we're in the sub menu that has all the tools that we're going to be using. So the toolpath we're going to be defining is a cutting toolpath. So it's a 2D profile. There's only one option here, so you can just click on the toolbar button or on the menu option, and that'll bring up the dialog box. The tool we want to select is our 0.01 laser cutter that we imported on a previous video. So if you haven't done the importing of the tool information, you should watch that video and take care of that before proceeding. So I'm going to select that, and I'm going to hit OK. And that brings in the preview of the nozzle off of our universal laser, which is what we're using in this case. The cutting mode that we want to select is through auto or through high quality. Those are the two that produce the cutting geometry for the laser control software. So either one of those will work. The feed rates don't matter for the universal laser because those are set in the control software for the laser on that side. Geometry that we want to pick, you could go around and pick individual contours, but that's kind of slow and it has one drawback. I'm going to pick the face, and that picks all the contours of that face. And this should, in the future, if you add another hole or change the geometry, automatically update because you picked the face. We want to include all loops and make sure that we say start outside on that. You could add tabs if this were in danger of, say, falling through the grid. In this particular case, it's not. But if you added tabs, you could go in and you see it adds tabs there. You can define by distance, a whole bunch of different options there. That can be covered in another video in detail. The heights in this particular case don't do anything for the program because the Z axis on the universal laser is not controlled by Fusion's program. The passes, there is a setting we want to change here. We want to change compensation type to in computer. If you don't do that, it won't output the file properly. And then under the passes tab, under the linking tab, we want to make sure that we have lead in checked and that we change the distance to 0.03 inches. If you're in metric mode, make sure you type in IN. You could get away with about 1 millimeter, depending upon how small your features were. You may need to adjust this down further if you've got really small features. There's some cases where you might need to set that to 0. We also want a lead out in this case so that it pulls away from the part when it's done with the cutting passes. Okay, so with that, we can go ahead and hit OK. We've got all our settings set, and it should go and apply toolpath. And if we go to a straight on view, you can see you have this blue line on the outside that shows you that you've offset a tool radius, and in this case it's 5 thousandths. Then what we want to do is we want to simulate and verify the tool, mostly for one, to see that it worked, and two, to see that it's cut in the right order. When you're doing laser cutting or water jetting, you usually want to cut out the internal features, the holes, any slots, rectangular cutouts, whatever you have on the inside. You want to cut those out first, because if you cut the outside out and you're not using tabs, that material could shift and change the location of those in an uncontrolled way. So I personally like to turn the model off when I'm simulating laser parts, and I leave the toolpath on. At that point in time, you can simulate. And you can see that it's cutting this out first. That's what we want. And then it moves over and does the outer perimeter. And when it's finished, you can zoom in and see the details. This is our lead in and lead out. That starts the laser out here in a piece of scrap and then moves into the part. You can see that there are small radius in the corner That's the diameter of, or excuse me, that's the radius of the tool. In this case, it's the laser beam. So you can just go get a quick visual on the different aspects of what that simulation will show you. So with that, we're going to close the simulation down. I'm going to turn the models back on, go to a home view, and I'm going to save my part to make sure I don't lose any of my settings. And that concludes this video.